Good afternoon, gang. This week we're going to be talking about rational and proportional relationships. We've talked about proportional relationships, but in terms of graphing and how proportions and ratios are set up to help us find our slopes. So today we're just going to use rational and proportional ideas to solve other problems. And so let's look at how that works. For part A, it says using a table of equivalent ratios to find a missing quantity. So we're going to look, and we're given tables here in both sections, and they're going to claim that they have equivalent ratios. So it says for part A and part B, choose the correct description, then fill in the blanks necessary. So in order to know whether or not our ratios are equivalent, we first have to simplify our ratios. Alright, so our first step here is to simplify each ratio. So we have to go through and compare tickets per point. And so what you would do is you would just start by simplifying your ratios. Our first ratio is going to be 20 over 2, and that equals 10 over 1. So for every ticket, or every point, we earn 1 ticket. Our next ratio is 54 to 6, and in this case we're going to earn for every 1 point we're going to earn 9 tickets. And as you can see, that these are not proportional. They don't always give the same number of tickets. So right away we can always say each point does not always give the same number of tickets. So we're looking for equivalent ratios. We want all of our ratios to be the same. So after you simplify each ratio, you need to compare them. We need to compare our ratios. And as we compare them, we have to make sure that they are all equal. So we need to note, as we compare our ratios, they have to be equal. And here they aren't. But if they were, we would then use our ratio to answer the question. So let's look at our second example. Part B, it says a local store is selling fresh tuna. The table shows the price listed for the amount of tuna. So in pounds per dollar, or dollars per pound is how we should look at it. The price of each tuna is not always the same, or the price per tuna appears to be the same. So here again we've got to check our ratios and compare them. So I want to know price per dollar, or price per pound. So let's look at, we'll just keep it the same. We'll do 2 over 8. Well, that equals 1 over 4. The next one is 5 over 20. That also equals 1 over 4. So far our ratios are the same. Let's check 7 over 28. Again, that equals 1 over 4. So our ratios appear to all be the same. The price for each pound of tuna, so 1 pound of tuna costs $4, appears to be the same. So the next question is, how much would it cost for $32 of tuna? Well, for $32 of tuna, we're going to get 8 pounds of fish. And the way we could figure it out is we could set up our proportions, say 1 over 4 is equal to x over 32, and so basically we would end up doing 4x equals 32, divide by 4, and x is going to equal 8. So we'd set up a proportion and use 8 as our answer. So this is part 3, using our ratio to answer our question. So remember, simplify the ratios and compare them, make sure they're equal, and then use your ratio to answer your question. Good luck, gang.